Good afternoon, good morning, or good day. So our lesson for today is about lesson number 5 and 6 under aquaculture subject. So this is about a basic estimation and calculation. So the objective first for the lesson number 5, at the end of this unit, you should be able to estimate the quantities of materials and resources required to complete a work task or appropriate and also apply appropriate mathematical operation to comply with the job requirements and calculate the whole numbers, fractions, percentages, and mixed number. For the introduction to basic estimation, we all know that aquaculture is a complex operation of growing fish and other aquatic animals. So it requires definite action in order to effectively produce fish. So there are different activities that is need a precise quantities that includes applying a fertilizer or the dosage of fertilizer in the pond, determining the number of fish to be stocked in a particular area, feeding fish with the recommended amount of feeds, and monitoring the growth of the gained of the fish. So therefore, the ability of knowing the estimate or knowing the estimation and the ability to be accurate is an essential skills needed in aquaculture. So in this lesson, this will provide us the basic computation and the basic estimation needed in aquaculture. So it covers the use of ratio and proportion in determining the amount of fertilizer that we need to apply into the pond, and knowing the numbers of the fish to be stocked. And also it includes the use of mean and average in determining the average body weight of the fish, solving for the daily feed allowance. So for the terminologies we have here, the average means also called the mean, the sum of all numbers in a distribution divided by the number of samples. Divisions, it expresses a relation in size between quantities. So let's start with the mean or average. So to compute for the average body weight or ABW of the fish, use this formula. So the formula ABW is equal to total weight of fish samples divided by the number of samples. So we have here a example or problem. Number one, so the table shows that the result of the fish sampling activity data below conducted by a grade 8 aquaculture students. So we need to compute for the ABW. So let's watch this video of how to compute the ABW. The average body weight of example number one or problem number one. Okay, our formula is ABW is equal to total weight of fish sample divided by the number of samples. So all we have to do is add the total of the total weight of fish sample given in the table number 1 or sample number 1 to up to 10. So that is ABW is equal to 5.5 plus 8 plus 5 plus 12.1 plus 5.8 plus 5.2 plus 7.6 plus 6.9 plus 9.2 plus 5.4 divided by our number of sample is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is divided by 10. So ABW is equal to
70.7, add this one, divided by 10. So ABW is equal to 70.7 divided by 10, that is 7.07 grams. So this is our answer.
Okay, so for
The
the next
average body weight.
subtopic is how to compute the daily feed allowance. So for the daily feed allowance, we have the formula.
Daily feed allowance, we
Um,
follow the
DFA W times N times S times R. So where W is means average body weight of the stock after a given period, N is equal to the origin number of stocks, S estimated number of survival rate, R is the feeding rate. So we have here two example, but definitely our we will have the first one sample. So given the number of stock in 1 hectare fish pond, which is 35,000, average body weight is after 30 days, so that is 8 grams. Estimated survival rate is 95% or 0.95. Feeding rate is 8% or 0.08. So take note that from the given data above,
formula.
the
DFA
the estimate survival rate, which is the 95% and the 8%, it should be converted into decimal point. Yeah. So let's watch this video.
is equal to W times N times S times R, where W is the average body weight, N is the number of stock, S is the estimated number of survival rate, then R is the feeding rate. So if the problem or the given problem is number of stock is equal to 35,000, average body weight is equal to 8 grams, estimated survival rate is 95%. So you need to convert percentage into decimal point. So 95% is equal to 0.95. Decimal point yon. So when you say feeding rate, that is 8%. So convert it into decimal point. So that is 0.08. So for the solution, we follow first the formula. So this is our solution. So our formula is DFA is equal to W times N times S times R. So is equal to W is the average body weight, which is 8 grams. So 8 grams times N is the number of stock, which is 35,000, times S is the estimated survival rate, which is 95% or 0.95. And our feeding rate is 8%. Convert that into decimal point, so that is 0.08. So multiply 8 times 35,000 times 0.95 times 0.08. Our answer is 21,280 grams. So divided by 1,000 because we need to convert grams into kilogram. So bakit why 1,000? Because 1 kilogram is equal to 1,000 grams. So 21,280 grams divided by 1,000. Okay, so our answer because we need to convert grams into kilogram. So bakit why 1,000? Because 1 kilogram is equal to 1,000 grams. So 21,280 grams divided by 1,000. Okay, so our answer now is 21.28 kilograms. So this is the
Okay, for the feed formulation, by the way, is a process of mixing together
formulation.
a various
Uh,
ingredients in a right proportion to produce a nutritional balanced diet. So the right proportion of the ingredients is calculated using the Pearson square method. So using the Pearson square technique, so we follow the different steps or instruction. The first one, we draw a square and write desired protein level of the diet in the middle of the square. Place the two ingredients ingredients in their protein content on the left side corner of the square, subtracting the protein content of each ingredient from the desired protein level of the feed. Write the difference at the corner of the square diagonally opposite to the ingredient. Take absolute value only, that is, you ignore positive and negative sign. Take the sum of the numbers at the right of the square to get the divisor, then divide the number at the right side corner of the square. Using the divisor, multiply to 100 to get the percentage. So we have here the given example. We have diet with two ingredients. So balance a 30% protein diet with the following ingredients. So we need to use the fish meat, which is 60% crude protein, and rice bran, 8% crude protein. So this is how we solve the problem.
Example, the diet with two ingredients, balance a 30% protein diet with the following ingredients: fish meat, 60% crude oil, and rice bran, 8% crude oil. So again, we use the Pearson square technique. So first is draw a square and write the protein level of the diet in the middle. So that is 30. Then next, place the two ingredients and their protein content on the left side of the square. So this is the two ingredients, 60% and the 8%. Next step is subtract the protein content of each ingredients from the desired protein level of the feed. Write the difference of the corner of the square diagonally opposite the ingredients. Take the absolute value only, ignore positive and negative sign. So 60 minus 30, so that is 30, so that's diagonal. 8 minus 30, so that is 22. Okay, to get the 2 plus 30, it's equal to 52. So we have our divisor. So, and then multiply to 100 to get the percentage. So 22 divided by 52 times 100, our answer is 42.31%. And then 30 divided by 52 times 100, our answer is 57.69%. So this is our answer now. Okay, to get the, if the answer is correct, all we have to do is add the two. So 42.31% plus 57.69%, that's the total of 100%. So meaning, therefore, the 100% or 100-gram diet with 30% protein, 57.69 grams rice bran, and 42.31 grams of the fish meal are needed.
Okay, so for the next subtopic, we have the bill estimate and cost estimate. So for the bill estimate and cost estimate, estimating a quantity of materials to complete the work task, preparing a bill of materials and cost estimate is very important and necessary to complete a work task. So prices of the materials, remember that's vary depending on the locality and the supply materials. So as you can see, we have here the table. We have the different materials, sample materials such as gravel, sand, CHB, Portland, and cement, and steel bar. And then we have the quantity, the unit cost, and the total cost. Remember, okay, during the filling of the table, if the total is not available, as you can see in the table, if the total is not available, all you have to do is multiply quantity times unit cost. If the unit cost is not available, as you can see in the table, all you have to do is divide total to quantity. While if the quantity is not available, all you have to do is divide to total to unit cost. So to understand it better, let's watch this video.
For the bill estimates and cost estimate, we have here the given example or the given problems table. So as you can see, the total is not available, the unit cost is not available, and the quantity of steel bar is not available. So if the total is not available, all you have to do is multiply quantity and unit cost. So 1 times 1,400, your answer is 1,400. So if the unit cost is not available, all you have to do is divide total divided by quantity. So 800 divided by 180, your answer is 5.50 or 550 per CHB. So if the quantity is not available, all you have to do is divide the total and the unit cost. So 2,800 divided by 175. So your answer is 16 pieces of steel bar. And then that's the time for you to total the amount of your expenses. So 1,400 plus 1,000 plus 800 plus 4,186 plus 2,800. Your total expenses is 10,186 pesos. For
Okay, so next, lesson number 6 is all about perform the basic calculation. So for the introduction of the basic calculation, under this topic, we have the temperature subtopic, measurement, perimeter, circumference, and area, and also volume. So we all know that metric system of the measurement is very important and useful in all fields of study, even in aquaculture. So in fact, because of its international appeal, scientists adopted it as a basis of measurements. So regardless of whether it is a fish pond, fish pen, or fish cage, or even fish pen, it is necessary for fish farmers to have a sound knowledge on how to determine the perimeter, the area, or the volume of the aquaculture facility. So an accurate estimation of perimeter area or volume of a particular facility is needed to determine other forms or other farm inputs, such as the amount of water, pesticides needed, and fertilizer to be used. So it is also useful for calculating construction materials and stocking density. So in this lesson, this will provide aquaculture students or you the necessary information to develop your skills in measurements. So you will learn conversion and of temperature and conversion of metric units, determining the perimeter area, and also the volume of aquaculture facilities. So before that, the terminologies that you will meet in this lesson or in this part, we have area, the number of square units contained in figure, circle, a small closed figure on a plane of which all points are equidistant from point called center. Then we have circumference, the perimeter of a circle, diameter, a segment from one point of the circle to another point passing through the center, perimeter, a distance around the polygon, prism, a polyhedron with two polygonal bases laying in a parallel planes and with other faces that are parallelogram, radius, a line segment that joins the center and the point of a circle or in the circle. Volume is the amount of space that a solid object contains. So first subtopic, we have temperature. So for the temperature, to convert Fahrenheit reading to Celsius, we use the formula. So degree Celsius is equal to 5 divided by 9, open parenthesis, degree Fahrenheit minus 32. 32 is constant. So we have here a sample, number 1 and number 2. So let's watch the video of how to compute or to get um, the converted Fahrenheit to Celsius.
For the computation of temperature, the conversion of Fahrenheit to Celsius and conversion of Celsius to Fahrenheit. For Fahrenheit to Celsius, we follow the formula degree Celsius is equal to 5 divided by 9 times degree Fahrenheit minus 32. So if we have an example number 1, 50 degree Fahrenheit, the solution is follow the formula. So, degree Celsius is equal to 5 divided by 9 times our Fahrenheit is 50. So, 50 degree Fahrenheit minus 32. So, degree Celsius is equal to 5 divided by 9. 50 minus 32, that is 18. So, degree Fahrenheit is equal to 5 divided by 9 times 18. So our answer is 10 degree Celsius.
Okay, so that is number one. So for to convert the Celsius reading to Fahrenheit, use the formula. So we have here the formula. Degree Fahrenheit is equal to 9 divided by 9 times degree Celsius plus 32. So we have here the number one example, 40 degrees Celsius. What is degree Fahrenheit? Or what is the conversion of 40 degrees Celsius to degree Fahrenheit? Let's watch this video.
For the conversion of Celsius to Fahrenheit, we follow the formula. Degree Fahrenheit is equal to 9 divided by 5 times degree Celsius plus 32. So we have here example number 1, so 40 degrees Celsius. So the solution is degree Fahrenheit is equal to 9 divided by 5 times, which is our Celsius is 40 degrees Celsius plus 32. So degree Fahrenheit is equal to 9 divided by 5 times 40 is equal to 72. Okay, plus 32. Okay, so degree Fahrenheit is equal to 72 plus 32. Our answer is 104 degree Fahrenheit.
Okay, so that's how we compute temperature.
For
Okay, for the measurement, we have here the conversion of the different measurement. So if we are talking about the length measurement, so we have here measurement, 1 meter equivalent is 100 centimeter, 1 inch is equivalent to 2.54 centimeter, 1 foot is equivalent to 12 inches, 1 foot is equivalent to 0.3048 meter, and 1 meter is equivalent to 3.28 feet. So if we're talking about area measurement, 1 square feet is equivalent to 144 square inches. 1 square feet is equivalent to 929.03 square centimeter. 1 square meter is equivalent to 10.7639 square feet. 1 hectare is equivalent to 10,000 square meter. 1 hectare is equivalent to 2.47 acres, and 1 acre is equivalent to 43,560 square feet. If we are talking about weight measurement, 1 kilogram is equivalent to 1,000 grams, 1 gram is equivalent to 1,000 milligram, 1 metric ton is equivalent to 1,000 kilogram, 1 pound is equivalent to 16 ounces, and 1 pound is equivalent to 0.4536 kilogram. If we're going to talk about volume measurement, 1 liter is equivalent to 1,000 ml or milliliter, and 1 US gallon is equivalent to 3.7854 liters. So that's how we compute or convert measurements. Okay, now let's have perimeter, circumference, and area. So for the square-shaped facility, perimeter can be computed using the formula. We have the P is equal to S1 plus S2 plus S3 plus S4, or P is equal to 4S. S means sides, P means perimeter. And then to calculate the area, we use this formula. Area is equal to S times S, or S squared. So let's watch this video.
to compute the perimeter and circumference and also the area for the square, we use the formula for the perimeter. P is equal to S1 plus S2 plus S3 plus S4, or P is equal to 4S, while area of the square is equal to S times S, or S squared. So we have here a sample, so 4 meters of 4 sides of the square. So compute the perimeter using the formula. P is equal to S1 is 4 meter plus 4 meter plus 4 meter plus 4 meter. Your perimeter is 16 meter. So this is your answer. For the area, okay, follow the formula. S times S, so side times side, that is 4 meter times 4 meter. Your answer is 16 meter squared. So this is your answer. To com-
Okay, now for the computation for the rectangular facility or perimeter can be solved using this formula. So P is equal to S1 plus S2 plus S3 plus S4, or P is equal to 2 times L plus width, or length times width, where L is length and W is width. To calculate the rectangular facility area, use this formula. Area is equal to length times width. So we have here a sample. So which watch the video.
For the rectangular facilities, the formula is to get the perimeter, P is equal to S1 plus S2 plus S3 plus S4, or P is equal to 2 times length plus width. While to get the area of the rectangular facility, area is equal to length times width. So this is our problem or given. So we have the length of the rectangle is 4 meter and the other side is 2 meter. So to compute the perimeter, P is equal to S1 is 4 meter plus 2 meter plus 4 meter plus 2 meter. Your answer is 12 meter. So for the area, length times width, so 4 meter times 2 meter, your answer is 8 meter squared.
Okay, to compute perimeter, circumference, and area, so the circumference of a circular facility can be calculated using the formula. So we have here circumference, or C, is equal to 2 pi r, where C is our circumference, D is the diameter, and R is the radius. To calculate the circumference area, use this formula. Area is equal to pi r squared. So take note that the value of pi is equivalent to 3.1416 or 3.14. So we have here a sample. So we have the radius of the square is equal to 1.5 meter. So let's compute the circumference and the area. Watch this video.
To compute the circumference of the circle and the area of the circle, for the circumference, we follow the formula. C is equal to 2 pi r, where pi is equivalent to 3.14. For the area, we follow the formula. A is equal to pi r squared. So the given is we have the radius of the square, which is 1.5 meter. So let's compute the circumference. So C is equal to 2 times our pi is equivalent to 3.14 times our radius is 1.5 meter. So 3.14 times 1.5 meter times 2, our answer is 9.42 meter. So this is our circumference for the circle. For the area, this is our formula. So area is equal to pi, which is 3.14, then r squared. So r, our radius is 1.5. So since it's r squared, so it should be multiplied again in 1.5. So multiply to 1.5. So 1.5 times 1.5 times 3.14, our answer is 22.18 meter squared. So this is your area.
Okay, to find the volume of the aquaculture facilities, in aquaculture, the volume of the aquaculture facility is often expressed in cubic meter, so which is cubic meter, or M3. So liters or gallons, it is being calculated using the formula. So volume is equal to area times height. So we have here an example, a 50-meter long fish pond, 25-meter wide, and 1.5-meter depth can contain how many cubic meter of water. So how this is how we solved the problem.
To compute the volume, we follow the formula. Volume is equal to area times height. So if we have a problem, number one, a 50-meter long fish pond, 25-meter wide, and 1.5-meter depth can contain how many cubic meter of water? So first, you need to compute the area. So what is the area of this problem? So the area is 50-meter long of fish pond and 25-meter wide of the fish pond. So area, the formula of area is length times width. So 50 times 25, that is, okay, so our solution, so volume is equal to area. So 50 times 25, that is 1,250 meter squared. Then multiply by height. The height is given, which is 1.5 meter depth. So 1.5 meter. So our volume now is 1,250 meter squared times 1.5 meter. So our volume is 1,875 cubic meter. Okay, for the unit of the volume, it should be cubic.
Okay, so that's the end of our lesson for today, which is all about estimation or the basic estimation and basic calculation under aquaculture. Thank you very much and have a good day.